Hi, everyone. My name is Robin Mateos. I'm a coastal geologist with the Illinois State Geological Survey, and I'm part of a research group that is all about mapping sand. A lot of what we do is monitoring based. We fly drones, we run sonar, but the Sea Grant project that I'll be talking about today is aimed at mapping sand thickness, and that hasn't really been done in a long time along the Chicago lakefront, but it factors into a lot of other studies that we have ongoing, and it's of great interest to folks like the Chicago Park District and other coastal stakeholders that care about where sand is and how it moves about in the coastal zone. Next slide, please. And so this was really what got this going into high gear was that lake levels were recently really high, and you might have seen in the Chicago Tribune some of these photos of the destruction along the lakefront. There isn't that much sand, so that makes it even more important to know where it is and where it goes and how interconnected the different urban embayments and systems are. So the project objectives were essentially to map sand extents, sand thicknesses, and to facilitate an understanding of how interconnected the different environments are. Next, please. All right, so this is not so much hypothesis driven. This is just going out with fancy equipment, and we rented some fancy equipment. This is a seismic line. So what we're looking at here is a readout from essentially a much more powerful fish finder that doesn't just see maybe what's in the water column or map the lake bottom, but it can penetrate through the lake bottom with sonar and get reflections off of subsurface layers. So using this, we can see things like the bedrock surface, which is irregular and at great depth. We can see what the glacial materials are and where they exist. And for us, the most important part, where the sand is and its variable thickness and things like that. Part of the system is also what's on the beaches. So we collected something like 50 kilometers of ground penetrating radar data across about 20 beaches. Those are all the beaches between Evanston and the Indiana state line. And this is a readout from here. So the vertical axis is depth, the horizontal axis is distance. Sand is imaged very well using this method. This is an electromagnetic pulse that gets put into the ground, and at lithologic contact, such as the base of the beach, you get a return signal. So with this, we were able to map thicknesses and get volume estimates for Chicago beaches. Next. All right, so we're entering year two. Year one was all the geophysics, and I'm not the geophysicist of the group, so hopefully I did this justice. This is my summer. I'm gonna go out and do sampling because we're also interested in sand textures. Is the sand coarse? Is it fine? That has a bearing on what the organisms do in the water column or what the substrate characteristics are in general. So we're planning an offshore sampling effort and a coring effort to validate what the subsurface interpretations are. Next. And here is a general map of our current data extents. So the faint line you see is where we've been with our boats to image the subsurface that we'll use for our mapping. And the yellow dots are the proposed locations for our sampling efforts. Thank you.